Hello, everyone. This is Shinkai Samudzi. I'm the CEO and founder of Asobo, working with LTM to deliver eSums. And in particular, I'm going to walk you through the carbon dashboard within the eSums tool. So what you see in front of you is the carbon management module. So every screen here drives a decision and doesn't just display data. And that's a conscious design decision around how we structured and function this. And in particular, we looked at specific user types or user roles that are going to be actually using this. So in this demo, we're going to walk through from the perspective of a solar asset manager and show how a solar asset manager that's doing carbon reporting would actually use this. So starting with our first screen, the dashboard, the first thing we're going to see is the site configuration status. Now we have three sites here: the Nairobi Solar Farm, the Mombasa Rooftop, and the Lagos Hybrid. The green check marks mean that the O&M data, so the operations and maintenance data, is flowing automatically. This is flowing automatically from our O&M module, which connects directly with inverters and streams production data as well as other information from IoT devices within the site. Right, so all that data is now flowing into the carbon dashboard, and we're able to now leverage AI to review that carbon specific data to surface in this particular module. Now we see one next to Lagos Hybrid site that says setup, and so this is just an indicator that we need to actually set up the data connection. And so you can click on setup to open a modal window, and then this allows you to select the choice of how you want to do the integration, and then setting up the grid emission factor based on the country. So one other thing to note is there's a data quality indicator in the top right corner of this site configuration status. And this percent tells me how complete my data is. The gaps number shows what's missing. So if I were to click view gaps, it takes me to the inventory, the emissions inventory, which is the next screen, to show me what is actually missing. And so for the Nairobi Solar Farm, so the picture we saw on the dashboard was the overall data quality. And now what we're seeing here is the breakdown by individual site. So the Nairobi Solar Farm, the data quality score is 94%, and we see specifically what's missing there. We can click on the Improve button to identify what items are missing and what things we can do to improve the overall data quality. So again, direct link into something that's specifically actionable. Okay, going back to the dashboard, we see that there are three actions that we can take. So below the site configuration, there are three actions we can take. We can add a manual entry for any data that's not captured automatically through the systems that were connected. We can export a greenhouse gas report for compliance, and we can set up alerts for monitoring. Now, just below that, we have a number of KPI cards, and these show total emissions across all three sites. So these are broken down by Scope 1, so direct emissions from diesel generators vehicles, Scope 2, purchased directly from the grid, and Scope 3, supply chain and travel. And then from the standpoint of the year-to-date versus target card, right, this tells me where I am against my actual annual target. So the target is 1,500 tons of CO2 emitted per year for 2026. Here where we can see what our year-to-date achievement is. And then the carbon impact card just shows us what the net impact calculation is. So solar generation would avoid emissions compared to grid power, but O&M vehicles, so the trucks that you roll out to fix things on site, might add to emissions. So the net benefit shows the actual value that we're delivering. So here we can see the 207 in this case. All right, so the next screen is the emissions inventory, and this is essentially the audit trail. So we have Nairobi Solar Farm selected in the dropdown, as we showed before. We see the data quality with the gap of 1, and I kind of clicked already to show you what can be done to improve that. Now, scrolling down from an emissions inventory perspective, we now do an inventory of the individual and itemized Scope 1, Scope 2, and Scope 3 emissions. So we look at our direct emissions, we looked at our indirect emissions, and we look at the value chain emissions below that. If we look at some of the other sites, we can also identify what the gaps are for those other sites and what their other specific Scope 1, Scope 2, and Scope 3 emissions are as well. Okay, so the next screen is our performance monitor. So this is where we track against targets and see what actually needs our attention. So if you look at our annual target progress card, the target here is 1,500 tons of CO2 per year. So the current emissions is showing, essentially it shows right here. The variance tells me if I'm ahead or behind, and this progress bar, 65%, shows us or gives us a visualization of that. So below that is the alert section, and these are AI detected anomalies and data gaps, right? So again, we're streaming data from the inverters and from the actual sites via our O&M module, and the stream data is being pulled into this module, and we have different AI models that are specific to carbon, that are looking for alerts that are specific to carbon-related activity. So, for example, if you look at our first alert, which is the Mombasa rooftop, we can see that emissions are up by 40% versus last month. And so the system identified a root cause. Here was a 3-day grid outage that forced backup diesel. And so you can see what the direct CO2 impact is. Didn't really have to investigate anything, right? The system correlated the spike with the O&M data immediately and automatically. So scrolling down a little bit more, we can see another alert for the Lagos hybrid system, and we can see that there's missing data for October. And so in this case, we just need to upload the fuel receipts. So this is not an anomaly, but this is more of a data gap detection. And then lastly, we see, scrolling down a bit more, we have our monthly emissions trends. We can see from 2025 what our monthly emissions looked like across the year. Again, the performance by scope. But I want to draw your attention to the industry benchmark comparison, because this shows our intensity versus average as well as best in class. So you can see where we sit, but then also where that places us from an industry perspective in a percentile standpoint. Lastly is our reduction planner. And so this is where I decide what to do about the gaps that we've surfaced in these prior screens. So in this particular case, in our summary, we see that there's a potential to reduce by another 245 tons of CO2 per year. There are 6 discrete opportunities to achieve that reduction. The total investment required is a little over $172,000 USD. The average payback period for each individual improvement is just a little bit over 2.5 years. So in the scenario modeler section, we have 4 bars. So one that shows us where we'll end up if we do nothing. The second that shows us what's already in motion. The third shows us if we approved everything, what it would look like. And then the fourth is the actual 2026 target. So you can see here in this particular case that even if I do everything, there's still going to be a little bit of a gap for this target, which again probably gives us an opportunity to reassess what our targets are, but also to reassess even what the scope of possibility is within our overall system. So this points to some additional activities beyond what's on our existing sites in order to achieve that annual target that we're looking at for the year. So the gap metrics also show us what's needed, number of approved initiatives, etc. But additionally, there's a section to do what if analysis. So you can look at the specific options that we identified, the 8 different options we identified as opportunities to further reduce and get closer to our goal. Well, this allows us to see individually, from a line item perspective, what each individual item does from the standpoint of getting closer to that goal. So we can understand which items have more impact than others from a financial perspective, from a projected reduction perspective, from a timeline perspective. And again, it allows you to make more informed economic and operational decisions from that. So again, we look at the reduction opportunities table, the specific opportunities here. Again, these are the same options that we saw in the what if analysis to show here what the opportunities actually look like and what they actually are. We can use this table though to actually drive the selection. So whereas before the what if analysis just kind of gave us some information to think about, this reduction opportunities section allows us to start creating a roadmap for the actual improvements and the actual execution of these reduction opportunities. So here I've shown you 4 screens. You're able to drive 4 different classes of decisions. For example, the dashboard told me that Lagos isn't configured and needs setup. The inventory screen showed me exactly which data gaps to fix and how to do it, and gave me a direct line into actually doing it. The performance screen flagged the Mombasa spike and told me why it spiked, right? There's a grid outage that caused backup diesel use. And then finally, the reduction planner showed me that battery storage at Mombasa would prevent that exact scenario, and it would close another 120 tons of CO2 emitted per year for my gap. So that's the entire workflow from a carbon management perspective. It's not just reporting, it's not just dashboards, but it's actual decision support that leads to direct driving of actions and activities. Thank you.